Hello guys, Prathik this side. So today we'll be solving a LeetCode problem 169 majority element. So let's first understand this problem. We have given an array nums of size n. We have to return the majority element. The majority element is the element that appears more than n by 2 times. We may assume that the majority element always exists in the array. So what this question is saying is we have to return the number of element that has a frequency greater than n by 2 times of the array. So let's first understand the constraints where n is nums.length equal to nums.length. N lies between 1 and 5 into 10 to the power 5, 5 into 10 to the power 4. And our nums I is between minus 10 to the power 9 and minus 10 to the power 9. And our input is generated so that the majority element will still exist in the array. And it says that can we follow the solution of the problem in linear time and one in space. So first understand this problem more with an example here. Our nums is given as 3 to 3. So for our the n here, our n divided by 2 would be 1.5 times. And as you can see, the frequency of 3 is 2, which is greater than 1.5. So we'll return 3 here. And for our nums 2 here, our nums to n is 7. So n divided by 2 would be 3.5. And we can see that 2 appears 4 times here. So we'll return 2 here. So let's talk about brute force approach here. Our brute force approach can be here to use a nested for loop to count the frequency manually for every element and see if it is greater than n by 2 times or not. And for our slightly optimized approach, we can use unordered map here to check for our frequencies. Uh, Now we'll just store our frequencies in our map here. Yes. Now, now we will write our if condition and check if MP num, if our frequency is greater than nums dot size divided by 2 or not. And if it is, we'll just simply return num here. And for our safe case, we will also write -1 here since we don't find our majority element. And now let's see if it is working for our code or not. Yes. And as you guys can see, it is passing our test cases. So let's just submit our code and see if it is passing all the test cases here. So in this, our time complexity is O(n) and our space complexity is also n. But as we saw earlier, we have had a follow up where we have to solve the problem in linear time and in one space. So if we look closely here, we can see that if we sort the array first and get the middle value of our array, it will always be the majority element because our majority element is covering the array more than n by 2 times. So if we get the middle element, we will always get the majority element. So what we'll do is we will sort our nums here, nums dot begin and sum nums dot end. And after this, we'll just simply return our element that is present in between here. Because as I said earlier from our observation, we can see that if we sort this array, it will become 2, 3, 3. And the middle element for this would be 3. And our same would be go for here, which will be our example that the middle element would always come with our majority element. Because n by 2 times, so our majority element will always cover the middle part of our array after sorting. So let's see if it is working for our code or not. And let's submit our code and see if it is working for all the test cases or not also. And as you can see, it is passing also all the test cases. And for this, our time complexity is O n log n, since our sorting takes log n time. And our space complexity has become O1, which is better than O(n). But we are still not doing our solution in linear time here. And we can do this problem with our follow-up, as our lead code said. with algorithm which is our Boyer-Moore voting algorithm, which we'll cover in our next video. So that's it from my side, guys, for this video. Thank you guys for watching.